Resume meeting. Okay. Reaction of acetylide anion. Okay. Terminal alkynes are readily convert to acetylide anion. Okay. Now, what meaning acetylide anion? We know the acetylene. This is the acetylene. Okay. Now, the acetylene, we know the hydrogen that bond on the carbon, triple bond carbon is acidic proton, acidic hydrogen. We say the proton. Okay. Why? Because the sp characteristic for the carbon, for the sp. Now, but it is weak acid, not strong acid. Now, then if we want to remove this proton from this carbon, we need strong base. Okay, strong base. By using strong base like NaH, NaNH2, strong base, acid-base reaction can be happen between the terminal alkyne and the strong base. Okay, to give you what? To give you the acetylide anion. Anion, that meaning negative charge on the carbon. Carbonium anion. Okay, carbonium anion, acetylide anion. Okay, now by simple word, acetylide anion is or nucleophile can be do as nucleophile. Okay, what meaning nucleophile? Nucleophile, that meaning can be attack something electron deficient, something partially positive charge, something with positive charge, like carbon with positive charge. Okay, then this can be do as nucleophile and can be attack the electrophile. Okay, to give you what? To give you carbon, a new bond carbon. Okay, be careful about that. To give you carbon, a new bond carbon. And inorganic reaction, talaba, every reaction give you carbon, new bond carbon is important reaction. Why? Because we need this reaction to build the structure. Okay, to build the structure, increase the molecular weight for the structure. Okay, it is very useful for the synthesis compound. Now, I hope you understand this. Now, the reaction of acetylide anion with alkyl halide. Yes, we said acetylide anion is nucleophile, can be attack the alkyl halide by SN2 reaction. Look, it will be come from the back side. SN2, you know the SN2 reaction. What meaning the SN2 reaction? And for the SN2 reaction, any compound of alkyl halide is the base for the SN2 reaction is the unhindered alkyl halide. Okay, that meaning alkyl halide with less steric effect here. Okay, that meaning just the primary alkyl halide, sometimes the secondary alkyl halide. Tertiary alkyl halide cannot be entered to the SN2 reaction. Now, you have the nucleophile here. This is the nucleophile. It will be attacked from the backside to remove the carbon halogen, and the halogen will be removed as good leaving group. Why? Because this halogen negative charge is a stable compound, stable anion. Okay, and you can see we have carbon here, a new bond R. This is the new bond. Okay, for this reason, this reaction is important. Because the acetylide anion are strong nucleophile, the mechanism of nucleophilic substitution is SN2. Yes, and thus the reaction is faster with primary alkyl halide, methyl primary alkyl halide. Okay, now the terminal alkyne. Why the primary alkyl halide? Because the less hindered or the less steric effect around the carbon that directly bonded to the leaving group. Now, for the terminal alkyne, reaction 1, this is the reaction 1, this is the reaction 1, sorry, or internal alkyne, this, okay, internal alkyne can be prepared depending on the identity of the acetylide anion. Now, if I want from you to prepare for me this compound, okay, to prepare for me this compound, that meaning we have a new bond here, okay, that meaning our nucleophile, it will be this here, the minus here, and this part, it will be come from the halide. Okay, that meaning this part, it will be come from the CH3Br, CH3Cl, and here look CH3Cl, and this nucleophile, it will be attacked, and this it will be removed to give you this compound. Okay, look to the second example also. You have this the acetylide anion, this acetylide anion, and this is a primary alkyl halide. That meaning this nucleophile, it will be attacked by SN2 reaction to remove the Br and to give you this compound. Okay. Now look to the starting material. How many carbon we have? 1, 2 carbon. Look to the product. 1, 2, 3, 4, 5. Okay. That meaning increase the molecular weight for the product. That meaning build a new structure for the product. For this reason, this reaction is so important. Okay. I hope you understand this. Look, he says although the nucleophilic substitution with acetylide anion is very valuable, carbon-carbon bond formation on the reaction, it has the same limitation as the SN2 reaction. Why? Where is the limitation? يعني محددة. Okay, not general for all the reaction. For what? For the SN2 reaction. Why? Dependent on your alkyl halide. That meaning, not all the alkyl halide is primary, secondary. There is tertiary alkyl halide. Okay, look, this tertiary alkyl halide. Okay, now, for the tertiary alkyl halide, we know the tertiary alkyl halide, sometimes the secondary also alkyl halide, cannot be entered to the SN2 reaction. Okay, because the steric effect here around the carbon, around this carbon. Okay, for this reason, if you have acetylide anion, and this acetylide anion cannot be attacked from here, from this carbon. Look, this carbon, I refer to you on this carbon. Steric hindrance prevent an SN2 reaction. Okay, that meaning this nucleophile cannot be attacked from here. Why? Because the steric effect, إعاقة فراغية. Now, what will be happen? You have acetylide anion strong base. Okay, for this reason, something it will be happen. Okay, what is the happen? This base search about the proton, search about something hydrogen partially positive. Okay, hydrogen acidic. Okay, where's the hydrogen acidic here? You have a 3. You have a 3 here. You have a 3 here. You have a 3 here. All this hydrogen is partially positive. That meaning partially positive charge. That meaning weak acid. Okay, acetylide anion strong base can be attack this proton, take it, and this is the hardo electron, 2 electron here, it will be convert to make you double bond here, and this it will be remove or leave the structure, leave out, go out from the structure to give you alkene, to give you elimination E2 reaction. Okay, to give you E2 reaction, not SN2 reaction. Depended on what? Depended on the structure of the alkyl halide. Be careful about that. Okay, dependent on the structure of the alkyl halide. Okay, that meaning when I give you reaction, I want from you to write the product, think about the reaction. Okay, if you have alkyl halide, this alkyl halide can be entered by elimination reaction, can be entered substitution reaction. Anyone is the best, the substitution or the elimination. And you can decide, in that time, you can decide the structure of the product. The product, it will be come from the elimination or it will be come from the substitution reaction. Okay, it is so important. Be careful about that. And he looked to this. Draw the organic product formed in each reaction. Okay, now look to this. This is alkyl halide. Any alkyl halide, a primary alkyl halide. Now, this acetylide anion. Now, acetylide anion, a primary halide, it will be substitution or elimination. Of course, it will be substitution. That meaning it will be SN2 reaction. Why? Because this is a primary alkyl halide. Now, this nucleophile, it will be attack this carbon, and this leave the chlor, the halogen, it will be leave the structure to give you substitution reaction product, this substitution reaction product. Now, look to this. This is cyclic compound and this secondary alkyl halide. Okay, now the nucleophile, it is difficult to come from here, from the backside. There is no enough space. Okay, it is difficult to come from here and to attack this carbon and to leave the product. Okay, that meaning there is no substitution reaction to be happened here. Okay, what happened in this time? Now, in this time, it will be happened elimination reaction. Now, Where is the acidic proton? We have 2 acidic proton here and 2 acidic proton here. Okay. Now, this astellite anion, it will be attack this proton, look. Take this proton and give you a new bond here, and this leaves the structure. Now, your product is alkene elimination, come from the elimination reaction. Okay? No. It is clear. I think it is clear. And if you have a question, must understand, ask me. This is homework. Look to this homework. Draw the organic products formed in each reaction. Now, you have this terminal alkyne, ethine. Okay, now you have NaH. You know the NaH strong base. That meaning this, the hydrogen minus, it will be attack to give you astellite anion. And then astellite anion, this is primary alkyl halide, it will be attack this carbon to remove the halogen, okay, to give you the product. Write the structure, okay? You have to write the structure, okay? Also this, look, this use some, this in this line use strong base with a primary alkyl halide, but in this line use strong base with tertiary alkyl halide. Okay, now write the structure. And this, it will be a SN2 reaction, this elimination reaction, depending on the structure of the alkyl halide. Then, in that time, I say to you before that, you have to be careful about the alkyl halide, the structure of the alkyl halide, the type of the alkyl halide is a primary, secondary, tertiary. Okay, and then you can decide it. You can decide any reaction to be happen, substitution or elimination. Also, this homework for you, he said, what astellite anion and alkyl halide, look, what astellite anion and alkyl halide can be used to prepare each alkyne? I want to prepare this compound. Okay, now I want to from you to write the starting material. Okay, any astellite anion or any alkyl halide can be react together to give you this compound, or to give you this compound, or to give you this compound. That meaning this is a product. Okay, this is a product. I want the starting materials. Okay, think about that, and you can write the structure. Okay, now he said here, identify the terminal alkyl A and terminal alkyne B for the following sequence for the following reaction. Now, this, what is the structure of A and what is the structure of B? Now, look, this, the first step reaction with strong base, NaNH2, to give you astellite anion. Second one, astellite anion, it will be attack this. This is a primary alkyl halide, substitution. Yes, give you substitution. Now, again, another base that it will be remove this proton. Look here, it will be removed. Give you another astellite anion. Okay, with us also primary alkyl halide. This astellite anion will be attack and attack this carbon, and the halogen with minus charge, it will be removed from the structure to give you the final terminal alkyne. Okay, now we started, look, we started with 2 carbon, but the final result 1, 2, 3, 4, 5 carbon. That meaning our compound, it will be big structure. Okay, our compound, it will be have high molecular weight and increase the molecular weight. Okay, for this reason, this type of reaction is so important in organic synthesis. Okay, when you want to prepare a compound, and the important reaction is the carbon and new bond carbon. Why? Because this type of reaction you needed to build your structure. Okay, now reaction astellite anion with epoxide. طبعا epoxide is 3-member ring cycle. This is the cycle with a 3-member ring with 3 atoms. Okay, and 2 carbon, and the third one is the oxygen. We said epoxide. This type of the compound called epoxide. Now, if you have astellite anion, we take it before that. Astellite anion, it will be attack this carbon or this carbon. Why? You know the oxygen is high electronegativity atom. For this reason, it will be partially negative. And both of the carbon will be what? It will be partially positive. And this stellate anion is nucleophile. That meaning nucleophile, it will be attack the partially positive carbon. Okay. Now, what will be happened when the stellate anion attack the carbon bond oxygen, it will be open. This bond, it will be open. Okay, this bond, it will be open by what? By SN2 reaction. Why SN2? Because the stellate anion will become back from backside to attack the carbon. Okay, and this it will be open, yes, to give you this structure. Okay, this it will be open. Now, the structure it will be remain like this, oxygen minus, no, oxygen minus not stable. In our mixture we have water. Okay, that meaning this base it will be attack the proton of the water. It will be take a proton from the water molecule. Okay, to give you the final structure is alcohol. This alcohol with the triple bond. Okay. Now, if you have asymmetrical epoxide, that meaning if you make this epoxide two part, like this, two part. Look, this carbon, not like this carbon. This carbon, there is no substituent on this carbon. And this carbon, there is two methyl group. Now, a stellate anion is easy to attack this carbon or to attack this carbon. Anion is less steric effect. Of course, this is less steric effect. That meaning, this stellate anion, it will be attack this carbon, not this, to open this bond between the carbon oxygen and give you the product. The minus oxygen not stable, it will be attack or take a proton from the water molecule to give you the final product. Okay, this is also important and nice reaction. Actually, this nice reaction. I hope you understand this. طبعا draw the product of each reaction. This epoxide, I want to write the product. Okay. Also, this I want to write the product. Draw product from the draw the products formed when this, look, this stellate anion react with each compound. This compound react with this. What is the product? This compound react with B. What is the product? With this, with this, with this. I want to write the product. Okay. And be careful about E and F. Look, ethylene oxide followed by H2O. Okay, that meaning also this two-step reaction, be careful about that. I want from you to write the product. This homework for you. Also easy, not so difficult. Try to write the products. He said here, look, this type of a question, devise a synthesis of this compound from this and any other organic or inorganic reagent. Okay, I want to prepare this from this. As you like, you can use any reagent. Okay, you can use any reagent. But in our lecture, you need to use strong base. We know that. And look, the first step, this our standard material will be react with strong base to give you a stellate anion. And then a stellate anion, the useful alkyl halide, look, the useful alkyl halide, this carbon and this carbon and this carbon. 1, 2, 3 with halogen. 1, 2, 3 with the chlor. 1, 2, 3 with the brom. That meaning our new bond here. This our new bond here. This our new bond. That meaning this part, it will be coming from the alkyl halide. Okay, this here. This from here. Okay, that meaning it will be attack this carbon to remove the halogen and give you the target compound, that compound you want, the needed compound. Okay, this is also important. I said to you before that every reaction, the final result is carbon, new bond carbon is important reaction in organic chemistry. Now, this he say, devise synthesis of the following compound from the starting material having 2 carbon or fewer. Okay, now I want to prepare this from starting material just 2 carbon or fewer. Okay, at least we know that 2 fewer carbon is the ethine. Ethine with a strong base give you a stellate anion. Okay, a stellate anion with this give you this compound. Now, hydration reaction طبعا give you the hydrogen here the OH here, enol ketoform tautomerism to give you the final product. Okay, to give you the final product. This type of synthesis, we say the stepwise synthesis is so important. Look, 1, 2, 3 step. 3 step to give you this compound. Okay, that meaning if from ethane you prepare this compound, you prepare ketone. Okay, you prepare ketone. From the ethane you prepare ketone. That meaning you can found. Also, you can see the importance of this reaction. How from the ethane you prepare the ketone compound with the big structure. For this reason, I say to you, this type of reaction is so important. Okay, now chapter 5 until here it will be finished, and please resolve all the homework. If you have a question, ask me. If you don't have a question, you can leave the meeting. And see you next time, inshallah.